In the vast interstellar space, a human carrier travels the world. NASA's Voyager 1, launched in 1977, stands as the pinnacle of space exploration. This mission not only revolutionized our understanding of Jupiter, Saturn, and their many moons, but also gave us our first look at the mysterious and fascinating planets Uranus and Neptune. As you watch this video, imagine that the two Voyager probes are still powered up and traveling through interstellar space, an untouched landscape created by the people. In the middle of their journey to this uncharted territory, however, something disturbing happened aboard one of NASA's most famous spacecraft of the 20th century. He collects terrifying clues from the interstellar space. Is Voyager just encountering an unknown force? Are these signs messages from extraterrestrials? And if so, is it a friendly greeting or a threat? Join us as we explore Voyager's amazing journey and the puzzling clues that have intrigued scientists for decades. Since launch, Voyager 1 has flown more than 15 billion miles and Voyager 2 has flown more than 12 billion miles, so consider Voyager's vision, past achievements, and inheritance. Consider how these two studies and their findings inspired subsequent missions that NASA continues to operate today. In the future, imagine a time in the future when our sun turns into a red giant in billions of years. At that time, uninhabited, humans ran into another celestial body following the path created by the Voyager missions. It's both humbling and inspiring to envision that even in that distant era, the Voyagers will remain Earth's ambassadors, each serving as a time capsule from an era when intrepid explorers on our pale blue dot reached out to the stars. Beyond the scientific contributions of the Voyager mission, the probes themselves have captured the world's imagination by carrying greetings for potential extraterrestrial civilizations in the form of the Golden Records. While Pioneers 10 and 11 carried simple metal plaques, Voyager's Golden Records were far more ambitious, filled with images and sounds offering a snapshot of Earth's diverse life and culture to any potential discoverers. The Voyager mission stands out as one of NASA's most ambitious endeavors, collectively visiting more planets, discovering more moons, and capturing more images than any other spacecraft in NASA's history. The question arises, why were there two Voyagers? In the early days of NASA, flight systems often encountered anomalies, necessitating safe mode and shutting down instruments until further commands were received. Given the fly-by nature of the Voyager missions, anomalies could lead to missed encounters and lost scientific opportunities. Thus, having two spacecraft increased the mission's chances of success, a strategy later echoed in the Mars exploration rover Spirit and Opportunity. Reflecting on their grand tours of the solar system, the Voyagers provided invaluable insights through tens of thousands of images and measurements, fundamentally altering our comprehension of the outer planets. For instance, at Jupiter, they offered our initial detailed insights into the planet's atmospheric dynamics, revealing the counterclockwise rotation of the Great Red Spot and its interactions with smaller storms. Voyager's missions marked major milestones in space exploration, especially the study of the outer planets. Most importantly, they were the first missions to observe the soft, dusty ring around Jupiter. By drilling Jupiter's moon Io, they discovered volcanic activity. In addition, the linear features on Europa indicate an ocean beneath, making Ganymede the largest moon in the solar system. When the spacecraft traveled to Saturn, they carefully studied the structure and composition of the atmosphere. Voyager 1's observations of Titan's thick haze led to the idea of liquid hydrocarbons on the surface, an idea later confirmed by subsequent missions. The missions also discovered cracks and ripples in Saturn's rings, while Voyager 1 discovered 3 previously unknown moons: Atlas, Prometheus, and Pandora. Voyager 1 continued beyond the solar system, while Voyager 2 headed for Uranus. On Uranus, Voyager 2 revealed 11 new moons and 2 undiscovered rings. However, some features, such as Uranus' unique magnetic field and constant temperature across latitudes, remained elusive. Voyager 2's last visit, Neptune, had 6 new moons with rings. This spacecraft discovered the structure of Neptune, the magnetic field, and even the volcanic gases on the giant moon Triton. Eventually, the two Voyagers begin to drift into interstellar space, breaking through the heliopause, the region where the solar wind collapses against atmospheric pressure. Voyager 1 officially entered interstellar space in August 2012, a discovery confirmed by analysis of electromagnetic waves during a solar flare. This finding is contrary to expectations, as the electron density is higher in the interstellar regions than in the inner heliosphere. The date of the shift in electric currents and the massive decrease in solar particles was determined to be August 25, 2012, coincidentally the day of Neil Armstrong's death. Voyager 1 is currently 11.5 billion miles from the Sun. Interstellar space, the vast space between stars, is devoid of matter. About 70% hydrogen and 28% helium, these things came from the Big Bang. The remaining 2% is heavy gas and dust that comes from inside stars and is ejected into space by supernovae. Despite its small appearance, the interstellar medium is very important, the birthplace of the stars, showing its important role in the universe. As Voyager ventured beyond the heliopause, marking a historic moment, it became the first human-made object to explore this uncharted territory, where no spacecraft or human-touched object had ventured before. Scientists anticipated groundbreaking insights into space exploration and the fundamental question that has fascinated humanity for centuries. Are we alone in the universe? As we delve into the vastness of the cosmos, the discovery of exoplanets, particularly those in Earth's size range and within habitable zones, has intensified the search for extraterrestrial life. The Drake equation, though filled with many unknowns, offers hope for determining the existence of intelligent civilizations. Despite the immense potential for life in the universe, the apparent silence, known as the Fermi paradox, raises questions about why we have not yet encountered extraterrestrial intelligence. Voyager 1's journey into interstellar space has yielded valuable data, revealing intense cosmic radiation and illustrating the interaction between charged particles from the Sun and those emitted by other stars. Despite its age, the spacecraft continues to astonish engineers. In a notable example, in December 2017, Voyager 1 successfully employed its backup thrusters, unused since 1980, showcasing its resilience and potential for extended operational life. As we stand at the crossroads of the search for life beyond Earth, our increasing technological capabilities offer hope that we may one day find answers to the mysteries of the cosmos. The Allen Telescope Array in California recently achieved an extraordinary feat by detecting a signal from NASA's Voyager 1 probe, launched 46 years ago and currently hurtling toward the outer edges of our solar system, well beyond the orbit of Pluto. The observatory, which is dedicated to the search for extraterrestrial life, used 20 of its 42 satellite dishes, each more than 61 meters in diameter, to communicate with Voyager 1. The telescope records 15 minutes of data stored on disk, but the signal appears to be unrecognizable. Rumors of the signal range from encounters with mysterious forces in space to the mysterious idea of aliens abducting Voyager 1. Some say the signals are messages from the race superior to man, and the nature of these messages is not clear. Whether it's a friendly message or a threat, Voyager 1 will continue to travel 151 billion kilometers from Earth and will be pursued by NASA's Deep Space Network. The data transfer rate is 160 bits per second. Despite the slow data transfer rate, the research, powered by a device that converts heat from the radioactive decay of plutonium into electricity, has provided important information. But with annual output dropping by 4 watts, NASA is having trouble maintaining Voyager 1's performance. Celestial rays, which are important in determining the passage of the heliopause. Although both devices have been around for a few years, the reduction in power is significant. Looking ahead, the Voyagers may only last a few years, if all goes well, perhaps until the 2030s. But even with their instruments turned off, these spacecraft will continue their journeys. Among the stars, in 16,700 years, Voyager 1 will pass Proxima Centauri, our nearest star, followed by Voyager 2 36,000 years later. Both orbit the galaxy over millions of years, surviving the collapse of the Sun and the destruction of the heliosphere. These signal spacecraft can transmit the last message encoded in the golden records during their journey. Made of gold-plated copper and sealed in aluminum cases, these discs contain images, sounds, and messages designed to evoke the landscape. Although they may last billions of years, their existence depends on external conditions, and one of the threats is the dust particles of space. Dust particles can erode the spacecraft's surfaces over time, posing a challenge to the long-term preservation of artifacts from Voyager's missions. Interstellar cloud dynamics have been proposed to affect Voyager's orbits. These large, massive clouds can bend a spacecraft's orbit, leading it to new orbits, sometimes deeper into the galactic core or farther away. However, both Voyager spacecraft have gold plates with information engraved on their sides, placed on their bodies, reducing the risk of erosion. Over the next 5 billion years, a time that is more challenging to model, Voyagers may move through our galaxy without changing or being affected by shock waves and other external forces. As we contemplate their fate, the sense of wonder and adventure it inspires lasts for thousands of years.